Hi everyone, welcome to Brilliant Qatar. Today, in this session, we are going to discuss this electricity. Just we can directly come to the session. See here, now you can see that now I am sharing some pictures of important devices that which we are familiar in our daily life, right? One is a refrigerator, another is an electric lamp, it's an electric fan, and electric train. If I'm asking one question, what is the commonness or similarity what you can see in all these pictures? Yes, it is very clear, right? All these devices or these equipments, all these things are run by using a common energy, right? What it is? Electrical energy or electricity. Yes, in this session, we are going to discuss or we are going to know more about this electricity. We can go, right? Yes. In many of your mind, there may be a question which always making a doubt like this. What's the difference between electric current and electricity? Is both are same? Like that, in many of your mind, which may comes to, right? We can find out both are correct or not. For that, first, we can discuss about the case of this electricity. What is electricity? You know that in our daily life, we people may not be able to think about even a microsecond without this electricity, right? Yes. Even me also, I cannot be able to think about a second without this electricity. Because that much importance that which lies in our lives. So what does this electricity mean? Electricity is nothing, it's a form of energy. It's a form of energy that which constitute by the flow of electric charges. So electricity is a form of energy that which constitute by the flow of electric charges. What is the importance of or why we people are depending this electricity most or this form of energy most? Yes. First one, it has certain characteristics are there. It is a clean form of energy. As we are comparing with the many other forms of energy, this electrical energy is a clean form of energy. And secondly, this form of energy can be transmitted to very long distances through the conducting cables. Third one, it does not forming any environmental pollution. That's why I already mentioned it's a clean form of energy. And fourth, it's a very important one. See, this energy can be converted to many other forms very easily without any extravagance. For example, in our home, for operating the many devices like electric kettle, electric iron, electric fan, refrigerator, washing machine, music system, television, computer, in all these devices, we are using the same electricity only. But in all these devices, the conversion form of energy is happening in many different ways. So, this is a very important characteristics that which possessed by this electricity. That's why in our daily life, we people are depending this electricity the most. Now, we can come to the category of this. What is electric current? So, electric current, that term, that which may means you may be familiar with this term current. Like air current, water current, these are the familiar term which may come to our mind when we are thinking about the current, right? So what is this air current means? Air current means it is a flow of air. Water current, what it is? It is a flow of water. Like that, what may be electric current? Yes, it is a flow of electric charges. So the flow of electric charges is otherwise known as what? Electric current. Clear? So electric current is a flow of electric charges, whereas electricity is a form of energy that which constitute by the flow of this electric charges. That is a major difference between this electric current and electricity. Hope you understood this concept very well. Now, I just used one term, electric charge. What is this electric charge? Electric charge is an intrinsic property that which possessed by the fundamental particles like protons and electrons. By this intrinsic property, they can experience an electric force in between them. That intrinsic property possessed by both protons and electrons are fundamentally known as this electric charge. And this electric charge is symbolized by this letter E. So, E is a symbol that which is used to represent the amount of or the quantity of the charge that which possessed by both protons and electrons, and which has a magnitude. And the magnitude of the charge that which possessed by both protons and electrons, which are represented by the letter E and which has a magnitude of 1.6 into 10 to the power of minus 19 coulomb. So here I used one unit for representing the magnitude, right? What it is? Coulomb. So coulomb is a SI unit used for representing the quantity of the electric charge. Clear now? So like that, in every matter, there it's not consisting a single proton or a single electron or like that one. It's may consisting of plenty of electrons or protons there itself, right? For representing the total amount of the charge that which possessed by a body, we are using another term, so that's nothing, it is the Q. So the capital letter Q, here it is represents the total quantity of the charge that which possessed by a body. So how we can be to represent that one? For example, if you have taken a conducting wire, if it is consisting of only a single electron, what may be the total amount of the charge present in it? So if we can write Q is equal to 1e, right? And if it is present 2 electrons, how we can be to represent? So Q will becomes to be 2e. Like that, if it is present 5 electrons, how much will be the total charge in that one? So it will be equal to 5e. Like that, if it is consisting of plenty of, say it will be n number of electrons are present in it, each electron having a charge of E, then the total amount of that charge present in that conductor we can represent by using this formula of Q is equal to Ne. Don't forget, and Q is equal to Ne. And here for representing both the positive charge and the negative charge that which possessed by both the protons and electrons. Here the protons are possessing positive natured charge and the electrons are possessing negative natured charge. So for representing commonly we will use this formula just like this. Q is equal to plus or minus Ne, where N is a total number of charged particles present in it and E is a charge that which possessed by a single electron or a proton. Clear? So Q here it is representing the total charge that which present by a body, and where E is the amount of the charge or the magnitude of the charge that which possessed by a single electron or a proton. Hope you understood. And you know that in every electrical devices, this electricity has to be passed through it, right? Who constitute this electric charge to pass through them? Actually, who is carrying this electric charge? Basically, in conductors, you know that one, they are consisting of plenty of free electrons. So, these free electrons are itself act as be the charge carriers in good conductors. They carries this charge. And while the movement of these particles through the conducting wires, they constitute this electric current, or they made this flow of charges. Flow of charge is nothing, what it is? It is termed as electric current, right? So, the electric current is caused by the real flow of this free electrons through the conductors. In conductors, there is consisting of a plenty of free electrons present in it. So, now we want to study about another important thing. For the movement of or the flow of every electric charges, there they require what? A closed and a continuous path is required. A closed and a continuous path of electric charge is what we termed as electric circuit. So what is electric circuit? For maintaining the continuous flow of electric charge through any of the pathways, we should give them a closed and a continuous path. And this closed and the continuous path we are made by connecting the conducting wires with the equipments. So such a closed and the continuous path of electric charge is what we termed electric circuit. This electric circuit are of two types. They are of closed circuit and open circuit. So I just shared a picture here itself and you will get an idea from what actually this closed circuit and open circuit from this diagram, right? What is this closed circuit means? That means through that continuous path, the charge to flow that one, to make it flow, they will get a closed path. Such a circuit is what we call closed circuit. Only all the electrical equipments can work only in this closed circuit. While if you are making that circuit to be open, that means that we are not maintaining a closed path, then the circuit is termed as open circuit. In open circuit, the continuation of the charges are not getting a continuous path. So, they cannot be able to complete the circuit. So, the equipments cannot be able to operate it properly. Such circuits are what we call open circuit. For example, in our home, when we are switched on, if the current is there, definitely your lamp will glow, right? There in the room. While we are switching on, what we are doing? We are making that circuit to that lamp, we are making to be closed. So, through the closed circuit, the current is began to flow. So, we are getting this light energy be there itself, right? But when we are switch off, the same thing, what we are making the circuit to be open. So, in open circuit, the lamp cannot be able to function well. So, please keep it in your mind, the circuit is a closed and the continuous path of electric charges, and this means the circuits are divided into two categories, open circuits and closed circuits are there. Hope you understood all these things well. Now, we can go to again the electric current means. What is this electric current means? You know that the flow of electric charges constitute this electric current, right? See, the electric current can be represented by through any of these conducting wires or in a closed circuit, we can calculate this intensity of the electric current. See, the electric current can be calculated by using a formula of I is equal to Q over T, or by definition we can say intensity of the electric current may be defined as it is a time rate of flow of electric charge. The time rate of flow of electric charge through any cross-sectional area in unit time is what we call intensity of the electric current. So, the intensity of the electric current in any circuit, we can calculate it by using this phenomenon, means this equation of, this mathematical equation of I is equal to Q over T, where Q is the total amount of the charge that which crossing through the unit area in unit time, and T is the time for which that current is maintained. But in some equations, see, just we want to use, instead of this Q, just we want to use this formula Ne over T, where to find the total amount of the charge itself, we are using this formula Ne, and T is the time for which the current is maintained. So, don't forget, so the electric current means it is constituted by the flow of this electric charges. So, the time rate of flow of electric charges are simply defined as this electric current. Now, just we can be to see, think about the two different types of this current. You know that I already expressed that the electric current is constituted by the flow of real free electrons present in the conductor, right? So, here in this circuit, what I expressed here, that which indicating the real flow of the real current. Here, the real flow of this free electrons, here it is starting from its higher potential, it's represented by the negative terminal of the cell, and here it is from the higher potential to the lower potential itself, the free electrons are passing through it. And this flow of dot parts, means the blue dot parts, you can see there in this diagram, that which indicating the real flow of this electric current in a circuit. But at the time of invention of this electric current, the people are aware, means they are not aware about this electrons, the free electrons present in this metal. At that time, they may believe that the current was actually be formed by the flow of positive charged particles. And that flow, you know that if the flow of that positive charges only can be possible from their higher potential of this positive terminal of the cell to the negative terminal there itself, right? So, from this positive terminal to the negative terminal through this external circuit, and this type of this current is what we named right now. We are naming this current as conventional current. What is the name of this one? This type of this current, that which constituted by the flow of this positive charges, are what we call conventional current. See, you know one more thing, the direction of the conventional current is quite opposite to that of this real electronic current through the conductors. So don't forget, in every closed circuits, the real current is actually be maintained by the flow of free electrons. But at the time of invention of electric current, the people are not known to be these electrons. So they believe that the current is actually be made by the flow of positive charges. But still now, we are also using the same concept of conventional current, and the conventional current simply representing the flowing direction of the positive charges. So the flowing direction of the conventional current is quite opposite to that of this negative charged electrons through the circuit. So don't forget. So the direction of the conventional current is quite opposite to that of this electronic current. And it's be from positive terminal of the cell to the negative terminal through the external circuit, like this. Okay, now I hope you understood this concept of this conventional current, right? Now we can come to the next thing. Anyway, even if the current is passing through it, we already discussed about the mathematical expression, how to calculate the amount of current maintained in a circuit when certain amount of charges are passing through the conductor in a certain time, right? By using the formula of I is equal to Q over T, we can calculate the intensity of the current passing through every circuit, right? I is equal to Q over T. By using this formula, we can calculate the intensity of the current in every circuits. But there are certain devices, electrical devices, that which we are using to calculate or to find out or to measure the intensity of the current passing through every circuits. That device is nothing, it is what we call the ammeter. So ammeter is a device that which is used to measure the intensity of the current in any electrical circuits. In ammeter, you can see that the intensity of the current is measured by a unit called ampere. Do you know how the name is given? The unit for measuring this intensity of the current in this kinds of this ammeter like devices, we are using this unit as ampere, as the honor of this eminent scientist Andre Marie Ampere. On behalf of him, we are still using the unit name for measuring the intensity of current as ampere. Now, in which manner we want to connect this ammeter to every electrical circuits to measure the intensity of the current passing through it, right? So it is a device used for measuring the total amount of the current passing through it, right? So the total current must be passing through that device itself. So that we should connect that ammeter in every circuit for measuring the intensity of the current. It should be connected in series. Don't forget. The ammeter should connect or should include in any of this electrical circuit to measure the intensity of the current in a series manner. So it should connect it in series manner. That means one after another. Because if we are connecting that ammeter in a series manner, then only the total current in the circuit will pass through that measuring device. Then only we can take the real measurement of the total amount of the current passing through it. But you know that one. In many of the electrical circuits, that may not be able to consisting of large amount of electric current. In such situations, we are using this milliammeters and microammeters are used for measuring these kinds of this feeble amount of electricity passing through the circuits. See, in milliammeters, the current that which measured in milliamperes, it is represented by small letter m and capital letter A, and we should read this one as milliampere. 1 milliampere is exactly equal to 10 raised to minus 3 amperes. Don't forget, 1 milliampere is equal to 10 raised to minus 3 amperes. That means through these kinds of this very sensitive devices, only a feeble amount of current can be measured. But there are still in certain electronic boards, see, through certain electronic components, there may be a very less amount of or very feeble amount of current may be passing through it. In such circuits, if you want to measure the amount of the current that which passing through it, the milliammeter or ammeter may not be able to sufficient, may not be able to use there itself for measuring that much current. Because the current that passing through that kind of this very sensitive circuits will be very less. And for such situations, we will use another type of the ammeter, that what we call microammeter. Microammeters are measured the current in the level of microampere. That 1 microampere, it is represented by 1 mu A. Here the Greek letter mu representing micro. Micro means 10 raised to minus 6. So in 1 microampere, there it consisting of 10 raised to minus 6 amperes are there. So don't forget, in 1 microampere, 10 raised to minus 6 amperes are present. So milliammeters are used for measuring the feeble amount of the current present in certain circuits, and in milliammeters, the current is measured in milliampere, and 1 milliampere is equal to 10 raised to minus 3 amperes. And in microammeters are still be used there in electronic circuits or in certain circuits that may consisting of very sensitive or very feeble amount of current passing through it, and in microammeters it is measured in microamperes, and in 1 microampere is exactly equal to 10 raised to minus 6 amperes. So this is all about the case of this measuring devices. I hope all of you understood all these concepts well. Now, we can summarize all these points, whatever the main points we discussed during this session. Just we can recapitulate once again. See, the first one, what is electric charge? What is electric charge? I already mentioned that one. It is an intrinsic property possessed by both protons and electrons, and which giving rise to experience the electric force in between them. That's property possessed by both protons and electrons are what we call electric charge. And the electric charge that which possessed by each of these protons and electrons are represented by the letter E, and which may having a magnitude of 1.6 into 10 to the power of minus 19 coulomb. What is the next point we discussed? It is regarding the electric current. What is the electric current we learned? Electric current is a continuous flow of electric charges from one place to another along a pathway required to make all the electrical device to work, and which is measured in amperes. That's what we call an electric current. Or in a simple manner, if you are saying, it is a time rate of flow of electric charges through any circuit is what we call electric current. The next, what are the mathematical expressions we learn for calculating the intensity of the current passing through any of the closed circuits or open circuits? See, in the open circuits, it may not be possible, but in the closed circuits, we are using these formulas. So, I is equal to Q over T, or it's equal to NE over T, where N is a total number of electrons present in it, and E is the charge of the single electron or the charge carriers present in it, and T is a time for which the current is maintained inside that circuit. So don't forget this formula for calculating the amount of current present in any circuits. I is equal to Q over T, or that's equal to NE over T, and which is a SI unit for measuring the intensity of the current passing through any of the circuits. It is measured in amperes. Don't forget, the SI unit for measuring the intensity of the electric current is ampere. How we can be to define 1 ampere? 1 ampere is that much current when 1 coulomb charge is passing through any conductor in 1 second. Don't forget, 1 ampere is that much current that which passing through any circuit in 1 second. So we can be write like this. Instead of this I, we can write 1 ampere like this. It's a SI unit for measuring the intensity of the current, and Q if you are setting to be 1 coulomb, and time if you are setting to be 1 second. Now we can see that if 1 coulomb charge is passing through any of the circuits through its unit cross-sectional area in 1 second in unit time, then we can say the intensity of the current developed in that circuit is taken to be 1 ampere like this. Hope you understood all these things. Now we can come to the next point. What we learned, the next important thing, that's regarding this electric circuit. What are electric circuit we discussed in this section? It is a closed and the continuous path of electric charge is what we call electric circuit. Electric circuit are of two kinds, which are the open circuit and closed circuit. Only electrical devices can be operated there in closed circuit, not in open circuit. So the last point what we discussed here, it is regarding the current measuring device. What is the name of the device that which used to measure the intensity of the current developed in any circuits? It was nothing, it is a ammeter. So ammeter is a device that which is used for measuring the electric current in a circuit. In ammeter, which unit it is used to measure in it? It is measured in amperes and it should be connected in series. All these are the very important points that we discussed in this session. Hope all of you understood this concept well. If you got all these points well, just we can recheck all these points, right? Through two numericals. Just we can directly go to one of the numericals. Are you ready now? We can do that one. Yes. Here I give you one question. Or if you please go through this one and I will explain that question first. Once we are getting in the numerical section, everybody know it well. Once we are getting these kinds of these questions, we should thoroughly read the question and we should be to understand what the questioner try to saying through these types of the questions, right? So here I will read the question first. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through that circuit. So we want to find out the amount of the current or the electric charge or the current. See the amount of the electric charge that which passing through the circuits, we want to find it out here, right? How we can find out? So first, when we are getting these kinds of the questions, the first thing is understand the question. Then the second thing is the data collection. Just we can collect the data first. So here, the first thing it is given by the amount of the current that which passing through the circuit as 0.5 ampere, right? I is given by 0.5 ampere. And secondly, what it is given? The time for which the current is maintained inside the filament of the bulb. How much time the current was maintained inside the bulb? See, it is for a 10-minute duration, right? But in SI system, you know that one. Time is not measured in minutes. So we want to convert it into what? Seconds. In 1 minute, everybody know that in 1 minute, there is 60 seconds are there, right? Like that, in 10 minutes, how many seconds will be there? So we should be to multiply this 10 with 60 seconds. That will be giving the time in seconds, right? So here 10 into 60, that will be equal to 600 seconds. So the time duration for which the current is maintained inside the filament of the bulb is around 600 seconds. So we got two quantities. What it is? I and T we already got, right? Now just we want to find out what the intensity means, the amount of the charge, right? So we know I and T, but we want to calculate what Q. So can we use this formula I is equal to Q over T? From that, we can make an equation for Q. So we will get from this formula Q is equal to IT, and the value of I here it is 0.5 ampere and the T is equal to 600 seconds. So 0.5 into 600 seconds will give you what? 300 coulomb. So here the total quantity of the charge that which passed through the filament of this lamp for a duration of 10 minutes is equal to 300 coulombs of charge it was passed. Hope all of you understood this answering well. Now we can come to the next question. Calculate the number of electrons that which constituting 1 coulomb of charge. So what we want to find out? Calculate the number of electrons constituting in 1 coulomb of charge. How we can find out that one? So which formula we can follow here itself? Here we want to find out what? The total coulomb of charge we want to find. Sorry, the total amount of the charge is given. But we want to find out how many number of electrons we require to make that much quantity of the charge, right? So for that, can I use, see, first what I said, when we are getting such a numerical question, first we should go through the question, try to understand it, and then the second step is the data collection. Here, what are the data they given here? Here the total amount of the charge is given, right? So we can given Q is equal to how much? 1 coulomb of charge. It is already given, right? Next, what do we want to find out? Calculate the number of electrons. So we can write N is equal to put the question mark. But we want to find out the number of electrons. So that charged particles name they mentioned. So we know that what is the amount of the charge that which means possessed by these electrons? We already learned that the charge that which possessed by the electron, which can be represented by using the symbol E. So E is equal to how much? We already learned that one. 1.6 into 10 to the power of minus 19 coulomb. This is the quantity of the charge that which possessed by this electron. I am not putting the negative sign here itself because only I am considering the magnitude, because here only I need the number of electrons only. That's why I am not using this negative sign here itself. Otherwise, if you want to consider the charge with the polarity, we should possess the negative sign here. We should put the negative sign over there itself. So we can come to the equation. By connecting this Q and N and E, which formula here we can use? We already learned one formula, right? What it is? Q is equal to NE, which this formula we already learned. Where Q is a total amount of the charge and N is a total number of charge carrying particles present there, and E is the amount of the charge that which possessed by the fundamental charge carrier, right? So here the charge carrier is electron. So we can substitute that values to be here in this formula, and thereby we can find out the number here. So for that, first we want to make a suitable formula for solving our problem. So here we want to find out this N. So I am making a formula for N first. So from this formula, can I write like this? N is equal to Q over E. In this formula, I can substitute the values of Q and E, right? What is the value of Q? It's equal to 1 coulomb. And what's the value of E? It's equal to 1.6 into 10 to the power of minus 19 coulomb. So can I cancel this? Both the coulombs here, both the units, it's here in this step itself, it's already be cancelled. And we can bring, we can bring the same formula, we can rewrite like this. I am bringing this 10 raised to minus 19 to the numerator. So I will get the formula just like this, 10 raised to plus 19 over 1.6. So again we can re-reduce this one. I am taking here from this value itself, it is very clear. Here 19 tens are present there, right? So from this 19 tens, I am taking only 1 10 out. So I will get 10 into remaining how many tens will be there? It will be having 18 number of tens are there. So I will get just like this over 1.6. By solving, now I can easily be solved 10 divided by 1.6, right? By 10 divided by 1.6, I will get the value just like this. Can I write this value here where I can be right? See here I will write the value of this N because the space is not sufficient here. So I am writing the answer to be here itself by solving that value of 10 into 10 to the power of 18 over 1.6. So I will get the value as 6.25 into the 10 to the power of 18 number of electrons. So this is the number of electrons that which constituting this 1 coulomb of charge. I hope everybody understood this concept as well and you enjoyed this session well. Then we can see with a new topic in the next session. Till then, stay safe, stay healthy. Thank you.